Okay, so this is SOA question 215 from the SOA Exam P practice problem set. And what this tells us is that the distribution of the size of claims paid under an insurance policy has probability density function f of x is equal to c times x to the a, defined over the interval x is between 0 and 5, and 0 otherwise. And I'm going to define my random variable x as x is equal to the size of claims paid under an insurance policy. So we have that right there. So we defined our variable and we have our distribution function. And this is defined for a is greater than 0 and c is greater than 0. So we can see that a and c are some constants. So our goal here in the end is we want to be able to use these a and c to find what they're asking of us. And what they're asking of us is, well, before we get there, we have one more piece of information. And that piece of information is that for a randomly selected claim, the probability that the size of the claim is less than 3.75 is 0.4871. So let me write that down. It's a lot to take in, but let me just write that down. The probability that x is less than 3.75 is equal to 0.4871. So we have this right here, and this piece of information is going to be important to getting our final answer. But what it wants us to do is it wants to calculate the probability that x is greater than 4. So we don't know this. So using all of our information here, what our best step is to, step 1, we want to find c in terms of a. And the reason that we're doing this is because we have two unknown constants, and our best way to find one of those constants is to get our entire equation in terms of that, and so we can solve for it. So how are we going to go about doing that? Well, what we can do is we can use our definition of the cumulative distribution function, which says that if we integrate our density function, f of x here, over its entire interval, it'll equal 1. This is just the definition of your distribution function, your cumulative distribution function. So what is this interval? Well, we're given that the interval is defined from 0 to 5, so let's write that down, 0 to 5. So if we integrate over this region, it's going to equal our probability of 1. So let's do that. Let's integrate from 0 to 5. Our density function is cx to the a dx is equal to 1. This is a pretty simple integral. We can do that really quickly. This is going to be 0 to 5, no extra steps. Cx to the a dx is equal to, this is going to be c times, it's going to be 1 over a plus 1, x to the a plus 1, evaluated from 0 to 5, that's going to equal 1. So now with this step right here, let's evaluate our bounds. Let's just do that. So I'm going to factor out a c, just so that way we can skip a step. We're going to have 5 to the a plus 1 over a plus 1 minus 0 to the a plus 1 over a plus 1. That's going to equal 1. Notice right here that this term, 0 to the a plus 1, 0 to any number is just going to be 0. That's going to be 0. So we're left with c times 5 to the a plus 1 over a plus 1 is equal to 1. So we're so close to getting c in terms of a. So let's solve for this. We're just going to flip this. We're just going to flip our fraction here when we divide it to the other side. So that's going to mean c is equal to a plus 1 over 5 to the a plus 1. And that's our first step done. Now let's move on to our second step. Just going to write this over here. Step 2. Our step 2 is to actually find the value of a. We can't do anything until we find the value of a. So when we find a, well, how do we find a? Well, we're given this information up here at the beginning of the problem, probability that x is less than 3.75 is equal to 0.4871. Notice that this right here, this is just your cumulative distribution function, big F of x, evaluated at 3.75, and that's equal to 0.4871. Well, we already know what our cumulative distribution function is. We found it in step 1. So I'm going to skip right down here because this is what's important here. This is our distribution. C times 1 over a plus 1, x to the a plus 1. And if you don't understand how we got here, I'm going to explain it. So we have our distribution function, cumulative distribution function. We're taking that right here because we already took this integral, so we don't need to do it again. But we have to be careful with our bounds here. So this is the cumulative distribution function goes from the lower bound 0 to 3.75 because this is the sum of the total area up until 3.75. That's what the cumulative distribution function represents. So we're going to set this equal to 0.4871. So now what we can do is we can evaluate these bounds. Again, I'm going to factor a c out just for simplicity. We're going to have 3.75 to the a plus 1 over a plus 1 minus 0 to the a plus 1 over a plus 1 equals 0.4871. Okay. This is pretty simple enough. Again, the 0 is going to cancel out. So we're left with c times 3.75 to the a plus 1 all over a plus 1 is equal to 0.4871. Well, we already found c over here. Look right here. We have c. So let's just substitute that into this equation over here. C is equal to a plus 1 over 5 to the a plus 1 times, we're going to do 3.75 to the a plus 1 over a plus 1 is equal to 0.4871. See right here, these terms cancel out because we have a plus 1 in the numerator and a plus 1 in the denominator. And now what we're going to do is we're going to put this in the numerator and put this in the denominator. What I'm going to do, since these exponents have the same sign, since these exponents are the same, I'm just going to rewrite this as 3.75 over 5 to the a plus 1. Use just properties of exponents. We can do that. Equals 0.4871. Now how am I going to solve for a? Well, you should already be thinking natural log, because if we take the natural log of both sides, we can use our log properties to take this exponent and bring it out in front of the natural log. So we're going to have a plus 1 out in front here. I just took this exponent and brought it out. Is equal to the natural log of 0.4871. So now that we have this, let's divide both sides by this quantity right here, the natural log of 3.75 over 5. So now a plus 1 is going to equal that quantity. And if we get our calculators out, let's take the natural log of 0.4871 divided by the natural log of 3.75 divided by 5. So a plus 1 is going to be 2.5. So we're going to have a is equal to 1.5. So now we've completed step 2 of this process. So what's left to do? Well, we still have to solve for the probability that x is greater than 4. So let's do that. So step 3, find probability that x is greater than 4. And if you're confused as to why we're not finding c in this example, you can find c. You can find the value of c. It's not necessarily going to make the problem easier or harder, but you'll see that when we move along in step 3, that it's not necessary to find c. If you'd like to, you certainly can, but you don't have to. So we're trying to find the probability that x is greater than 4. What is that? Well, we know that our integral, we're going to be integrating f of x dx. Okay, so that's going to be our bounds. Our bounds are going to be 4 to 5, because our upper bound is 5. Our interval is defined from 0 to 5, and we want the probability that x is greater than 4. So this is going to be equal to 4 to 5. We have our density function is equal to cx, and a is 1.5 dx. Well, we already know this integral. We've done it 2 times already. So this is going to be 1 over 1.5 plus 1. I just substitute in 1.5 for a. X to the 1.5 plus 1 times our c, evaluated from 4 to 5. Well, let's evaluate this. Again, I'm going to factor out my c. So we're going to have 5 to the 2.5 over 2.5 minus 4 to the 2.5 over 2.5. And then I'm going to bring in my c here. So when I substitute in my c, as we found here, c is equal to a plus 1 over 5 to the a plus 1. So c is equal to 2.5 over 5 to the 2.5. And then we multiply by, I'm going to combine these two fractions. So I'm going to have 5 to the 2.5 minus 4 to the 2.5 over 2.5. These two terms cancel out. So we're left with 5 to the 2.5 minus 4 to the 2.5 over 5 to the 2.5. Well, what do we have now? This is something that we can use our calculator for. So 5 to the 2.5 minus 4 to the 2.5 all over 5 to the 2.5. That's going to give us 0.428, or without truncating or rounding, 0.4275. But in this case, this is all we need, because our answer here, if we look at our problem, is B, 0.428, and that is our answer. So I hope you found this video useful. If you have any questions, just comment them down below. And if you'd like me to cover any other questions, I can do so.